College Trigonometry, Chapter 9, Section 5, Trig, Equations and Inequalities, Part 1. Now, I'm going to warn you, this is pretty much straight up just examples. We're going to do example. I think pretty much what I'm going to do is talk you through most of these, although if you want to, you are certainly welcome to pause the recording and try it on your own. So I'll give you a brief second to pause the recording, and then we'll talk through these. There's a lot of different methods and a lot of different styles of equations and inequalities. So you need to pay attention to what we're doing and what the equation looks like that we're using that particular method with. We're taking this slow. We're spreading this section over a couple of days in class. The same for Section 6, which will be Part 2 of Equations and Inequalities. So the first thing we're going to do is we're going to solve 2 sine x minus 1 equals 0. We're going to use linear methods, which is kind of what you'd use if you just had 3x plus 12 equals 9. You do the same type of thing. That's the technique we're going to use. So if you want to pause it and try it, go ahead. If not, we're going to keep going. Also notice we're solving it from 0 to 2 pi. 2 pi is not included because its value and 0 would be the same. So we're only doing this over one period. We'll talk about what happens when they want a general answer later. So the first thing we're going to do is we're going to add 1 to both sides. So we have 2 sine of x equals 1. Then divide by 2. Now we can do that because the 2 is in front of the sign. If the 2 had been in front of the x, we could not do that. We cannot pull the 2 out if it's in front of the x, but it's in front of the sign, so it's fine. So we have the sine of x equals 1/2. So we need to remember what has a sine of 1/2. And we're going to give our answers in radians, and we have a big clue of that because they told us to go from 0 to 2 pi. If you want to think in terms of degrees, sine of 1/2 would be 30 degrees, which in radians is pi over 6. And then you need to find the other value around the unit circle that's going to give us a sine of 1/2, and that's going to be 5 pi over 6. That's going to be in quadrant 2. So my two answers are pi over 6 and 5 pi over 6. Graphing calculator, you can kind of do the same thing. You graph it, and what we're looking for is where the graph hits the x-axis. So you would do a calculate 0. Now the problem with this is that it is going to give you a decimal approximation. If they want an exact answer, a decimal approximation is not going to get you credit. So you need to only use this method for either A, backup, where you can check your answers, or B, if they say give an approximation, then you can use the graph. Now we're going to solve a couple of inequalities. Now notice both of these are the same as the equation. We have 2 sine of x minus 1 on one side and 0 on the other. One of them is a greater than and one of them is a less than. And again, if you want to pause, go ahead. Otherwise, we're going to keep going. We've already done the hard part. We've already identified that it equals 0 at pi over 6 and 5 pi over 6. And this is where your graph can come in handy. If 2 sine of x minus 1 is greater than 0, that means we're asking where is this graph above the x-axis? And if you look at the graph, that happens between pi over 6 and 5 pi over 6. And then the second part, less than 0, where is this graph below the x-axis? And that's going to be from 0 to pi over 6, and then from 5 pi over 6 to 2 pi. And you see that answer given using interval and set notation there. All right, now, notice at the top it says we're going to be factoring this time. So what we're going to do, you might already have kind of an idea of what we're going to do. I'll give you a hint in case you want to try this on your own. We're going to subtract the sine of theta from both sides so that this thing equals 0. And then, as the top says, we're going to factor. Now notice this time we're going from 0 to 360, so we're going to be using degrees this time. If you want to pause, go ahead. Otherwise, continue the recording and we'll talk through this one. As I said, you want to subtract the sine of theta from both sides. Now notice that all that did was put a minus sine of theta after sine theta, tan theta. But notice those two terms now have a common factor of sine. So we have the sine of theta times the tangent of theta minus 1 equals 0. And what we'll do is we'll set those two factors equal to 0. So sine of theta equals 0, or tangent of theta minus 1 equals 0, which means the tangent is 1. Okay, for the sine of theta equals 0, we get the answers 0 and 180. So your sine is 0 at 0 degrees and 180 degrees. Tangent equals 1 at 45 degrees. It's also going to equal 180 degrees around the circle from that at 225 degrees. So all of those make up our solution set. Notice the caution here. It's really tempting to say, ooh, there's a sine theta on both sides. I'm going to divide by that. The problem is that if you divide by the sine of theta and get rid of it, you're going to be missing half of your solutions. So you don't want to do that. You want to do the technique that we're doing here. You'll probably be able to use a lot of these if you take note of them, and as you go through your homework, you can kind of match the problem on the homework to the problems we're going over and use them as a guide. All right, so we're going to try solving these two problems over the interval 0 to 2 pi. Now, notice that this is a quadratic type. So what's really easy to do with this is to kind of think of it, instead of tan squared of x plus tan x minus 2, think of it being x squared plus x minus 2. And then you can factor to use the quadratic formula. If you want to try it on your own, pause and give it a go. Otherwise, continue and we'll talk through this. Okay, like I said, it's kind of like a quadratic equation. So again, if you want to think about it as being x squared plus x minus 2, it would be x minus 1 times x plus 2, and then go and put the tangents back in. So it's tangent of x minus 1 times tangent of x plus 2. We set each of those equal to 0, and we get the tangent of x by itself for each of those. So we have that the tangent of x is 1 or negative 2. And then you figure out the solutions for both of those. Now, for the first one, we can get the exact solution, so we're going to do that. The tangent is 1 at pi over 4 and 5 pi over 4. For tangent of x equals negative 2, that's not one of our special values. It doesn't belong to a special angle. So what you need to do is go make sure your calculator's in radian mode and do the inverse of the tangent of negative 2. And that's going to give us negative 1.107, it says, however, due to the way the calculator determines this value, it is not in the desired interval. Because the period of the tangent function is pi, we add pi and then 2 pi to this answer to get the solutions. In other words, if you think about it, the inverse tangent, the domain for that, or the range, is negative pi over 2 to pi over 2. We want our answer to be between 0 and 2 pi. So what you need to do is convert that to where would it be, what would the value be, what would the angle be in the first quadrant, and what would the angle be in the third quadrant. And that's why we're adding the values to that. And you get your answers there. I'm sorry, actually that would be the second quadrant and the fourth quadrant. So that's what they're adding. You add the pi to get the second quadrant, and then the 2 pi gives you the fourth quadrant value. So that may be a little bit hard on the brain, but it's kind of one of those weird things from having the limited domain. And you see the solution set there. Okay, part B was asking about an inequality. Well, if you now know where it equals 0, you need to graph it. And when you graph it, now you're going to notice there's some asymptotes there. So you're going to have to break at the asymptotes. But if you look at it, it lies above the x-axis from pi over 4 to pi over 2. And then there's a break. There's an asymptote there. So pi over 2 to 2.03. And then from 5 pi over 4 to 3 pi over 2. And 3 pi over 2 to 5.18. It's a little complicated because of the asymptotes. That's why they have that break there in between values. All right, this time we're going to do something similar, but we're going to use the quadratic formula, which may sound a little bizarre, but hang in there. It's actually not that bad. Now what we're going to do is we're actually going to distribute the cotangent into the cotangent x plus 3, and then we're going to subtract the 1. In other words, we need it to look like a quadratic equation. Now, if you want to go on your own from there and give it a try, knowing we're going to use the quadratic formula, pause the recording. Otherwise, keep playing and we'll continue. Okay, so you're going to rewrite the expression and, like I said, distribute and subtract the 1. So you get cotangent squared of x plus 3 cotangent x minus 1. Now, think of the cotangent as being the x. A is 1, because that's what's in front of cotangent squared. B is 3, that's when it's in front of cotangent, and C is negative 1. And then cotangent of x is your x, it's the variable. So instead of x equals negative b plus or minus, you're going to do cotangent x equals. Now, having that information, if you'd like to pause and give it a try, go ahead. Otherwise, keep playing and we'll continue on to the final solution. So here's what it looks like. The cotangent of x is negative 3 plus or minus the square root of 13 over 2, and they got 2 decimal values for that. Now it says we can't take the inverse cotangent, so we have to use the fact that cotangent of x is 1 over tangent of x. Okay, so what they're showing you here is that if the cotangent of x is negative 3.30277, and notice we actually have the same answer, it's just one's positive, one's negative. If that's the cotangent, then the tangent is negative 0.30277. You might be saying, well, where did they get that? They did 1 over the cotangent, because that's what the tangent is. And then they did second tangent of that. You can kind of wrap that all up and do it in one step by doing second tangent 1 divided by, and then doing the cotangent. Now, the first of these is not in the desired interval. Okay, what does that mean? Well, remember, tangent goes from negative pi over 2 to pi over 2, but cotangent goes from 0 to pi. So what we're going to do is we're actually just going to add pi to that negative 0.294, and that's going to give us one that is in the interval. And then we add the 2 pi to get the second answer, because we want to go all the way around the circle. We want to go from 0 to 2 pi. So adding pi and then 2 pi to our negative answer gives us 2.847 and then 5.989. The second value is in the correct interval, and we need to know what the value is, the other value is, so we're going to add pi to that, and that gives us our second value for that one. So we have our solution there. All right, here's another one. Now this one you can, if you want to, why don't you try this one on your own. You can use the quadratic formula with this one, however this one will factor. So you've got 2 techniques we've already tried. You can use either one on this. Pause the recording, give it a try, and resume to check your answer. Okay, so they chose to factor it. You're not going to see the solution using quadratic here, although you should come up with the same answer if you do it correctly. So we have factors into sine of x plus 3 times sine of x minus 2. So sine of x plus 3 equals 0, or sine of x minus 2 equals 0. Notice we get sine of x equals negative 3, or sine of x equals 2. Well, there's a problem with that. If you remember, the range of sine is negative 1 to 1, and neither of these numbers are in that range. So what that means is that this problem has no solution. I know some of you are probably going, okay, I just did a whole bunch of work and I got nothing out of it. Sorry, but sometimes that's the way it works. There's no solution to this problem. All right, now we're going to try another one with a slightly different technique, and you can see at the top it says we're going to square and then do trig substitution. So if you remember those formulas I told you needed to know that aren't on the sheet, the Pythagorean identities and the reciprocal identities and the quotient identities, those are going to come into play in these equations from time to time. So you need to make sure you know them. If you didn't learn them the first time around, you need to get them down again, and you're going to need them for the test anyway. So it's a good time to go ahead and get those back down. If you want to give it a try on your own, go ahead. Otherwise, keep going and we will go over the answer. So you may have guessed what we're going to do is square both sides. And when we do that, so imagine that there's a parentheses and a square around tangent x plus square root of 3, and then we're going to square secant also, so we square both sides. You must FOIL the left side out. So tangent x plus the square root of 3 squared, when you FOIL it, gives you tangent squared of x plus 2 square root of 3 tangent x plus 3 equals secant squared of x. And then what they have done is they said, well, you know what? Secant squared of x is 1 plus tangent squared of x. So they replaced it. Well, what does that do? It gives us an equation where all of our trig functions are the same, which is much easier to solve. So notice that what we can then do is subtract the tangent squared of x from both sides. We could subtract the 3 from both sides, so we get 2 square root of 3 tangent x equals negative 2. Dividing, we get tangent of x is negative 1 over the square root of 3, or negative square root of 3 over 3. And thinking about our unit circle or about our special triangles, we know that when it's over 3, that indicates that it's going to be something over 6. So it's going to be 5 pi over 6 or 11 pi over 6. And then what you do need to do is go back and check those and make sure they work. Because we did do quite a bit of changing, and you can get extraneous solutions with this. When you go back and put the numbers in, the only one that works is 11 pi over 6. So steps to solving a trig equation. First of all, decide whether it's linear or quadratic, because that's going to determine what you do to solve it. If there's only one trig function present, then you just solve for that function. So if it's only got tangents in it or it's only got sines in it, it makes it a little easier, and you just kind of get that function on one side, get everything else on the other. If there's more than one trig function involved, rearrange the equation so that one side equals 0 and try to factor. So see if factoring will take care of it. If it's in quadratic form and you can't factor it, use the quadratic formula. And you may need to use trig identities to change the form of the equation. And they say squaring can be very helpful because it lets you use the Pythagorean identities. If you do that, you do need to check for extraneous values. Graphically, if the equation is f of x equals g of x, then what you can do is make the left side y1, the right side y2, and then see where the graphs intersect. So you'll do second trace, intersect. If the equation equals 0, then just graph that as y1, and you're going to calculate zeros on your graph. Additional practice, so why don't you pause the recording, give these a try, resume to check your answer, and continue this way through the rest of the recording.